Here we have another problem which says expand s plus 2 raised to the power 5. So we can actually expand this using so many methods. The first one is the direct expansion method, right? Which you expand this directly, right? So using the knowledge of laws of indices, you know that a raised to the power 5 actually means a coming 5 times, which is a times a times a times a times a. 1, 2, 3, 4, 5. So with this, using that knowledge, x plus 2 raised to the power 5 means x plus 2 coming 5 times. So you expand, write it out in this form and do the direct expansion. Right. So another method is the Pascal's triangle, right? Using this, this is 1, 1, 2, 3, 3. This is 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5. So 2, 3, 4, 5. So you'll be using this expansion, Pascal triangle. That's the second method. While the third method is the combination method. And that's the method we'll be using to expand this. Right? Now let's get to the solving. Here, combination is what? N combination R is equal to n factorial over n minus R factorial R factorial. So we'll be putting this in this form, right? The n here is what? 5. So 5 combination 0. The next you have what? 5 combination 1 plus 5 combination 2 plus 5 combination 3 plus 5 combination 4 plus 5 combination 5. Remember you have your x and 2. So you have x and 2, x and 2, x and 2, x and 2, x2, x and 2. For x, you start from the highest n, which is 5. You go down in descending order till you get towards 0. Here we have x raised to the power 5. Here we have 4, 3, 2, 1, 0. Then for 2, you start from power 0 and go higher till you get towards 5. Here we have 2 raised to the power 0. 1, 2, 3, 4, 5. So you can see the pattern, right? You can see the pattern. So having known this, you need to find the value of all these. 5 combination 0, 5 combination 1, 5 combination 2, 5 combination 3, 5 combination 4, 5 combination 5, right? And using this formula here, we have that for n combination R is equal to 5 combination what? For this, 0 is equal to 5 factorial over n is still 5 minus 0 factorial. 0 factorial. N factorial is 5 times 4 times 3 times 2 times 1 over here. 5 minus 0 is still 5. So 5 factorial. 5 times 4 times 3 times 2 times 1. 0 factorial is 1 times 1. All this will give you 1. Right? So for this, 5 combination 1 is 5 combination 1 is equal to 5 factorial over 5 minus 1 factorial, 1 factorial. This will give you what? This will give you 5. Just cross check. This will give you 5. Then 5 combination 2. 5 factorial over 5 minus 2 factorial, 2 factorial. This will give you 10. Then for 5 combination 3, will give you what? Minus 3 factorial, factorial. This will also give you 10, right? So it has a pattern. Just observe the pattern. Then with this, 5 combination 4 will give you what? It will give you 5. It will give you 5 anyway. Minus 4 factorial, 4 factorial. This will give you 5. Then 5 combination 5 will give you 1. So you substitute the value of all these inside here. So for 5 combination 0 is what? 1 times s raised to power 5. 2 raised to power 0 is 1, because any number raised to power 0 is 1. Plus, for this you have what? 5. S power 4. 2 raised to power 1, you have 2, plus 5 combination 2 will give you 10. Right? You have s cubed. 2 raised to power 2 will give you 4. Plus 5 combination 3 will give you 10. X squared. 2 raised to power 3 will give you what? 8. Plus, here we have what? We have 5. X. 2 raised to power 4 will give you what? 16. 16. Plus, here we have what? 5 combination 5 will give you 1. S raised to power 0 will give you 1. 2 raised to power 5 will give you 32. 2 times 2 times 2 times 2 times 2 times 2 will give you 32. Right? So we simplify further. Here we have s raised to power 5 plus 5 times 2 will give you what? 5 times 2 will give you 10 s power 4 plus 10 times 4 will give you 40 s power 3 plus 10 times 8 will give you 80 s power 2 plus 5 times 16 will give you 80 x plus 32. So hence, the expansion of this x plus 2 power 5 is equal to all this here, everything you have here, which is s power 5 plus 10 power 4 plus 40 power 3 plus 80 power 2 plus 80x plus 32. Right? As simple as that.